Good day, students. Today we want to solve problems that involve balancing points from the zero end. The first thing is to analyze the question appropriately. Now, what you need to do, draw your meter rule. A meter rule is found to balance at the 51 centimeter mark. 51 centimeter mark. We assume that at this point, the mass that we are looking for, the mass of the meter rule, balances at this point, 51 centimeter mark. You stop there. Now say full stop. When a body of mass 70 gram is suspended at the 10 centimeter mark, the balance point is found to be at 25 centimeter mark. That means that at the 10 centimeter mark, when you suspend the mass 70 gram, the balance point is found. It's now moved. The balance point of the meter rule now moved to this point, which is 25 centimeter mark. 25 centimeter mark. We are now asked to find the mass of the ruler. We want to find the mass of the ruler. This mass of the ruler, when you shift it here, that means that the balancing points now shift from formerly 51. Now, what will be the mass equivalent at the other side that will balance the meter rule appropriately? Now, let's get the distances. If from here, this point to this point is 51, and you have from this point to the pivot fulcrum to be 25. When you subtract 25 from 51, you have 26 centimeter. You have 26 centimeter. Now, to get this point, 25 minus 10, you have 15 centimeter. Now, let's go to conditions of moment of a force. This clockwise moment as condition of equilibrium when the system is in equilibrium. This is anti-clockwise moment. Now, the condition of equilibrium is clockwise moment equals to anti-clockwise moment. And from there, you have mass in mg multiplied by the perpendicular distance times 26, mass in gram. The distance equals to 70 gram. 70 times 15. Now 26 mass in gram equals 70 times 15. Divide both sides by 26 by 26. 26 comes to 26 mass in gram equals, when you multiply it and divide, you have 40.38 gram. When you multiply, let's see, 70, write 150 times 7, 7 times 0, 0, 7 times 5, 35, carry 3, 7 times 1, 7, plus 3, 10. That's 1050 divided by 26. When you divide it, you have 40.38 gram. That's the mass of the meter that will balance the other mass when it's being shifted to 10 centimeter mark. Now let's see the B part. This is the A part. The B part, so find the mass, the distance of the balance point from zero end. from zero end, from the zero end. Okay, if the body were moved, instead of being at 10 centimeter, we are told that the body were moved to 20 centimeter mark. We don't know this one, let's call it Y. Okay, call it Y. The body were moved to this point, and it's still 70 gram. Instead of being at 10, it was moved to 20 centimeter mark. He said, what would be, he said, find the distance of the balance point from here to here. Don't forget that we have 51 formally, 51 centimeter. That's mg. I already know our mg, which is 40.38. Okay, now what we need to know is that 25 centimeter, also it has been shifted. We are not considering this 25 again. Now you now have, at this point from here to here, you have 51 minus y. 51 minus y. From here to here is 51 minus y. Okay, now from here to here you have y minus 20. Y minus 20. Okay, now let's now use clockwise moments. Clockwise moments, and this is anti-clockwise moments. Now in condition of equilibrium, when the system is in equilibrium, you have clockwise moments equal to anti-clockwise moments. You have mg, which is 40.38, open bracket, 51 minus y equals 70 anti-clockwise times, open bracket, y minus 20. Now let's open the bracket. When you multiply that, you have 40.38 multiplied by 51, you have 20. You have 2059.38 minus 40.38y equals 70y minus 1400. Okay, when you collect the like terms, you have 2059.38 plus 1400. Collect the like terms, 70y plus 40.38y. When you add them together, you have 3,459.38 equals 110.38y. You divide both sides by 110.38. 110.38 cancel each other. Therefore our y equals 31.38. 34 centimeters. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.